Hello there. Go ahead and find a comfortable place and somewhere you can settle in, somewhere quiet just for a little while. You can sit or lie down, it doesn't matter. What matters is this moment, this decision to pause. Let's just, to stop. The world outside is spinning so fast, isn't it? It's a blur of motion, of noise, of demands. But not in here. Not right now. This time this space is just for us, it's just for you. So go ahead. When you're ready, gently close your eyes. You won't be needing them for where we're going. Feel the weight of your body, the support of the chair or the bed beneath you. Just let yourself be held. Take a deep breath in, filling your lungs. And when you exhale, let it go. Let the day go, the emails you have to answer, the plans you have to make, the conversations you're replaying in your mind. Just let it all dissolve. It can all wait. It's just you and me and the sound of my voice. We are about to begin a journey. It isn't a trip you can pack a bag for. It's a journey we will take entirely in our minds. A journey of pure imagination. All you have to do is listen. Just listen and allow your own mind to paint the picture. We're going to look up. It's something we've always done. As long as there have been humans, we have looked up at the night sky. Imagine for a moment being someone else. A distant ancestor thousands and thousands of years ago. You are standing on an open plain or at the mouth of a cave. The fire at your back casts a small warm circle of light. But above you there is no city light. There is no smog. There is only a deep, perfect velvet black, and it is on fire with stars. Not just a few, but millions. A river of light so bright it casts a soft shadow on the ground. You would look up, you would have to, you couldn't not look. And in that moment a connection was made. A silent relationship forged between the small thinking creature on the ground and the vast silent wheeling universe above. That was sky. It wasn't just a beautiful sight, it was everything. It was a clock. The way the patterns of light shifted night after night told you when the seasons were turning. It told you when the cold was coming, when the rains would arrive, when to plant your crops. It was a map. Those reliable fixed points of light were the only guides. Sailors and travellers learned to read them, trusting their lives to those tiny distant fires as they crossed endless, featureless oceans. And it was a storybook. We are creatures who see patterns. We connect the dots. In that random scatter of light we saw hunters. We saw bears and queens and gods and lovers. We painted our myths, our greatest fears and our deepest hopes onto that black canvas. The sky was our first and greatest mystery. It was the source of our biggest, most human questions. Who are we? Where did we come from, and are we alone? That same sky is still there. Right now, above your head, above the clouds, above the ceiling, it is still there. And it is still asking those same questions. But it's so hard to hear them now, isn't it? Our modern lives are so complex. They are so full of screens, full of deadlines, full of notifications and alarms all shouting for our immediate attention. We are constantly busy. We fill every quiet moment with distraction. We check our phones while waiting in line. We listen to podcasts while we walk. We plan tomorrow's meetings while we eat dinner. We are constantly endlessly connected to information, and yet it's so easy to feel disconnected from the big picture, from the wonder. That is what we are here to do, to disconnect from the noise just for a little while. I want you to imagine taking all of those complications, the worry about work, the to-do list that never seems to end, the argument you had, the bill you need to pay. Take all of it. And in your mind, picture a small, simple box next to you. Open the lid, and one by one place those thoughts, those worries inside. They aren't gone forever. They are just not for now. They are not coming with us on this journey. They'll be right there when we get back if you really want to pick them up again. But for now, close the lid. Feel the sudden lightness. Feel the quiet that rushes in to fill the space where all that chatter used to be. This is your time. This is your permission to simply be. To let your mind, which has been running all day, finally unhook itself. Let it go, let it drift like a single perfect leaf on a slow, quiet stream. It doesn't need to go anywhere in particular, it's just floating. So where is this stream taking us? We are going to begin our voyage, but we have to be very clear about what kind of voyage this is. Our world is obsessed with speed. Faster internet, faster travel, faster results. We want to get from point A to point B in the shortest possible time. This is not that, this is the opposite. This is a journey of contemplation, a journey of slowness. We are not trying to conquer space, we are trying to appreciate it. We are not racing to a destination. We are savouring the view from every single step. Our journey begins right where you are, right in this room with your eyes closed, breathing quietly. We will start here with the familiar and then we will expand. We will travel together using only our thoughts. Let your mind drift upward, past the ceiling of your room, up past the roof of your building, rise above the sounds of your neighborhood, of your city. Watch the streets become a glowing map below. Watch the cars become tiny crawling lights. Push higher. Feel the air thin out. Watch the blue of the sky fade to the deep indigo of the edge of space. Watch the great gentle curve of our planet emerge, your home. And then we will keep going. We are going to journey from this very spot, from this exact moment, all the way out to our pale, silent moon. We will drift past the other planets in our cosmic backyard. We will fly through the great belt of asteroids past the giant swirling gas worlds and wave goodbye to the tiny frozen travelers at the very edge of our solar system. And we will not stop there. We will go to the edge of our galaxy, the edge of what we know, the edge of understanding itself. We will go not with the speed of a rocket, but with the quiet, persistent, unstoppable power of a thought. Are you ready? Relax, breathe. And let's begin. We start where we are, on this rock, our planet Earth. It feels huge, doesn't it? You can spend a lifetime exploring it and never see it all. We look up and see our companions, the moon, our constant silent neighbour, and the sun, the source of all our warmth and life. We know the names of the other planets: Mars, the red desert; Jupiter, the giant stormy king; Saturn with its impossible rings. This is our solar system. This system, our home, is vast. It takes a spacecraft years to travel from one planet to another. The outer edges, where comets sleep in a dark, cold region called the Oort cloud, are so far away that sunlight is just a faint pinpoint. This whole setup, our one star, our 8 planets, the asteroids and comets, is our neighborhood. But now I need you to do something. I need you to let go. Imagine you're in a ship that can travel faster than anything we've ever built. We are going to pull back. We leave Earth behind a blue and white marble. We pass Mars, we fly by the asteroid belt. We soar past Jupiter, feeling its immense gravity. We wave goodbye to Saturn. We pass the ice giants Uranus and Neptune. We push past the dark, frozen border of our system. Now we keep going, for years, for thousands of years at this impossible speed. What do we see? Our sun. Our beautiful bright sun shrinks. It becomes just another star. A bright one to be sure, but it joins a sea of other stars. We are now floating in the space between the stars. And as we pull back further and further and further, a new shape begins to emerge. We are not in an empty void. We are inside something. A flat spinning disk of light. A shape so vast it defies imagination. We are inside the Milky Way. This is our city, our galaxy. On the darkest nights, far from the lights of human cities, you can see a faint glowing band stretched across the heavens. It looks like a cloud or a river of spilled milk. This is where it gets its name. The ancient Greeks called it Galaxias Kyklos, the Milky Circle. The Romans called it Via Lactea, the Milky Way. They were not wrong. It is a river of stars. But this is no static painted picture. The Milky Way is a living, breathing, dynamic city. It is a colossal spinning structure made of gas, dark matter and stars. How many stars? The number is hard to truly grasp. Scientists estimate there are between 100 billion and 400 billion stars in our galaxy alone. Let that sink in. For every single person alive on Earth, there are at least 50 stars in our galaxy. Many of them are just like our sun. Many of them likely have planets. This city of stars is a spiral galaxy. If you could fly outside and look down on it from above, it would look like a beautiful shining pinwheel. It has a bright dense center called the bulge, which is full of old reddish stars. From this center, great arms of gas and dust spiral outwards. These arms are the industrial zones of the galaxy. They are where new stars are being born right now, formed from collapsing clouds of cosmic dust. This city is also incredibly flat. While it is vast across, it is relatively thin. It's shaped like a disc or perhaps 2 fried eggs clapped together back to back. Now we must talk about size. And this is where our human minds begin to fail. The only way to measure this city is to use a new kind of yardstick, the light year. A light year is a measure of distance, not time. Light is the fastest thing in the universe. It travels at an astonishing 26,000 miles or 300,000 kilometers per second. In the time it takes you to snap your fingers, a beam of light could circle the Earth 7 times. A light year is the distance that beam of light travels in 1 full year. It is an enormous distance, nearly 6 trillion miles or 9.5 trillion kilometers. Our galaxy, the Milky Way, is 100,000 light years across. What does that mean? It means if you sent a text message from one side of the galaxy to the other, Travelling at the speed of light, it would take 100,000 years for it to be delivered. Let's try the analogy from the outline. If the entire Milky Way galaxy was the size of a vast country like the entire continent of North America from coast to coast, how big would our solar system be? All the planets, all that space we thought was so huge, on this scale our entire solar system out to the farthest planet would be smaller than a single grain of sand. We are small, unimaginably small. We have not left our house, we have not even left our room. All of human history, every king, every war, every invention, every love story has taken place on a microscopic speck of dust floating inside a single building in a single city in a vast, sprawling country. So where is our house? Where is our little grain of sand located in this city? We do not live in the chaotic, dangerous, crowded downtown. The centre of the galaxy is a wild place packed with stars and radiation. We also don't live in the remote, empty countryside at the galaxy's edge where the materials for building stars and planets are scarce. We live in the suburbs. Our solar system is located in a quiet, peaceful neighbourhood. We are on a minor spiral arm, a sort of local lane called the Orion Spur. We are about halfway from the centre to the edge, roughly 26,000 light-years from the galactic core. This location is perhaps the reason we are here at all. We are in a Goldilocks spot. We are far enough from the violent centre to be safe from its intense radiation and the disruptive gravity of so many stars. We are also far enough from the empty outer regions to have a rich supply of the heavy elements, like carbon, oxygen and iron that are necessary to build rocky planets and ultimately life. These elements were forged in the hearts of ancient stars that lived and died before our sun was even born. We are in essence living in the cosmic suburbs, a perfect quiet zone where life has had the stability and the resources to evolve over billions of years. But what about the centre? What is at the heart of this sprawling city? If you point a telescope, especially one that can see in radio waves or infrared light, which can pass through the thick dust toward the constellation Sagittarius, you are looking toward the galactic core. It is a place of incredible energy. Stars are packed in thousands of times more densely than in our neighbourhood. And right at the very centre, at the precise point that our entire galaxy spins around, there is a monster. Or is it? It is an object called Sagittarius A star, and it is a supermassive black hole. We hear black hole and we think of a cosmic vacuum cleaner, a monster that sucks in everything in the universe. This is not true. A black hole is simply an object with so much mass stuff crushed into such a tiny space that its gravity becomes all-powerful. Past a certain point called the event horizon, nothing can escape its pull, not even light. This black hole Sagittarius A star is not a monster. It is an anchor. It is enormous. It has the mass of 4 million of our suns. But it is also incredibly small, compressed into a space smaller than the orbit of the planet Mercury. Because it is 26,000 light-years away, it has no effect on us. It will not eat our galaxy. It cannot pull us in. Instead, it is the gravitational anchor that holds the city together. Just as the sun's gravity holds the Earth and the other planets in their orbits, the immense gravity of Sagittarius A star holds our sun and all the other hundreds of billions of stars in their orbits. We know it's there even though it's invisible because we can watch the stars near it. Scientists have tracked the orbits of stars very close to the centre. They see them whipping around an empty dark spot at millions of miles per hour. They are moving so fast they must be orbiting something with tremendous unseen gravity. That something is Sagittarius A star. It is not a raging monster. It is a quiet, massive, powerful heart, the central axle on which our entire beautiful city of stars turns a peaceful giant in the centre of the chaotic, shining river of the Milky Way. So we've taken a tour of our magnificent home, the Milky Way galaxy. We've seen its spiral arms, its dense core, and the monster black hole lurking at its centre. It's easy to feel like this is the universe. That this spinning city of 400 billion stars is all that matters. But the moment we step outside, the moment we pull the camera back even further, we realise something profound. We are not alone. Our Milky Way is not a solitary island drifting in an infinite empty ocean. We are part of a family. We are part of a cosmic neighbourhood, a small cluster of galaxies, all bound together by their mutual gravity. We call this family the local group. Think of it like a small sprawling county out in the cosmic countryside. This county has maybe 50 to 100 different towns and villages. Most of them are small, quiet, dwarf galaxies with just a few million or a few billion stars. But this county has two major cities, two massive dominant spiral galaxies that anchor the entire region. One of those cities is our Milky Way, the other is our neighbour, our rival, and our twin, the Andromeda Galaxy. Andromeda, also known as M31, is the star of the local group. It is the most distant object you can see from Earth with your unaided eye. On a clear dark night far from city lights, you can spot it in the constellation Andromeda as a faint, fuzzy, elongated patch of light. It doesn't look like much, just a smudge. But that smudge is a city of 1 trillion stars. It's slightly larger than the Milky Way, more spread out and packed with even more stars. It is for all intents and purposes our big sister. And when you look at that smudge, you're participating in an act of cosmic time travel. Andromeda is 2.5 million light-years away. That means the light you are seeing tonight, the photons hitting your eyeball, left that galaxy 2.5 million years ago. It has been travelling through the cold emptiness of intergalactic space for all that time just to reach you. Think about what was happening on Earth 2.5 million years ago. Our distant ancestors like Australopithecus were walking upright on the African savanna. The first true humans were just beginning to evolve. We were a world of simple tools and vast open plains, completely unaware of the cosmic drama playing out above. When we look at Andromeda, we are not seeing it as it is today. We are seeing it as it was when our own species was not even a whisper of a thought. And if there is an astronomer on a planet in the Andromeda Galaxy right now looking back at us with an listenable telescope, they are not seeing our cities, our satellites, or our civilization. They are seeing our galaxy as it was 2.5 million years in their past. They are seeing the world of our ape-like ancestors. This look-back time is a fundamental concept. The farther we look, the further back in time we see. The universe is a history book, and the speed of light is the page-turner. But Andromeda isn't just a pretty neighbour to look at. It's a neighbour with a very important appointment. For a long time, astronomers wondered if Andromeda was moving away from us like most galaxies do, as the universe expands, or moving toward us. After decades of careful measurement watching the way its light is shifted, we have the definitive answer. Andromeda is moving towards us. And it's moving fast. It is racing in our direction at over 250,000 miles per hour. That's over 100 kilometers every single second. It is being pulled relentlessly by the combined gravity of our two massive galaxies. This is not a maybe. This is a confirmed astronomical certainty. We are on a collision course. In approximately 4.5 billion years, the Milky Way and the Andromeda Galaxy will collide. Now I know what you're thinking. Collision. That sounds terrifying. It sounds like an apocalypse. You're imagining planets, crashing stars exploding, and universal chaos. But the reality is so much more subtle and so much more beautiful than that. The most important thing to remember about a galaxy is that it is almost entirely empty space. Yes, it has 400 billion stars, but the distance between those stars is beyond comprehension. If our sun were the size of a single grain of sand in Los Angeles, the nearest star, Proxima Centauri, would be another grain of sand in San Francisco. That is the kind of emptiness we are dealing with. So when the Milky Way and Andromeda collide, it's not a crash, it is a merger. Imagine two vast, thin clouds of smoke drifting across a room and slowly passing through each other. The clouds mix and swirl, but the individual smoke particles almost never touch. The same is true for the stars. The chances of any two stars physically colliding are practically zero. Our sun will almost certainly pass by its new neighbours from Andromeda without any trouble at all. So if the stars don't hit, what does happen? Gravity. The entire event is a cosmic dance choreographed by gravity. As the two galaxies get close, their mutual gravity will begin to tear them apart. They will stretch and warp. Our beautiful orderly spiral arms will be pulled and twisted, flung out into long fiery streamers of stars called tidal tails. For any civilization living on a planet at that time, the sky will be the most spectacular, terrifying, and beautiful sight in all of history. First, Andromeda will grow in the sky. It will go from a faint smudge to a huge, brilliant ribbon of light dominating the night. Then, as the two galaxies pass through each other, for the first time, the sky will be filled with a chaotic, swirling new set of stars. The gas clouds, however, will collide. Unlike the stars, the massive nebulas of gas and dust in both galaxies will slam into each other. This cosmic pileup will trigger an unimaginable burst of star formation. The merging galaxies will light up with the fire of trillions of newborn stars. The sky will be ablaze with new bright blue suns and glowing pink nebulae. After the first pass, the two galaxies will fly apart, but gravity won't let them go. They will slow down, stop, and fall back toward each other again and again. This cosmic sloshing will go on for hundreds of millions of years. With each pass, the structure is broken down. The spiral arms are gone, the neat flat disks are scrambled, the stars are thrown into new random looping orbits. Eventually, after perhaps 1 billion years of this violent dance, things will settle down. The Milky Way and Andromeda will be gone. In their place will be a new single gigantic entity. Scientists have already nicknamed it Milkomeda. This new galaxy will not be a spiral, it will be a massive round, somewhat disorganized elliptical galaxy. It will be a new home for all the stars from both galaxies now thoroughly mixed. Our sun and its planets will survive, but we will have a new address. We might be flung far out into the new halo, or we might find ourselves deep in the new chaotic core. And at the center of this new super galaxy, the two supermassive black holes, our Sagittarius A star and Andromeda's even larger companion, will begin their own slow final dance, spiraling toward each other over millions of years, until they too merge into one truly colossal black hole. This isn't an end, it's a beginning. It's the universe recycling itself. This is how the universe builds things, by merging smaller pieces into larger ones. This 4.5 billion year timeline is a long way off. But we don't have to wait for the future to see galactic mergers. We can see a preview happening right now in our own backyard. While Andromeda is our big sister, the Milky Way has its own tiny companions. If you are in the southern hemisphere, you can look up and see two fuzzy patches of light that are much closer and clearer than Andromeda. These are the large and small Magellanic Clouds. They are not clouds in our atmosphere. They are satellite galaxies. They are dwarf galaxies, small and messy, that are bound by the Milky Way's gravity. The large cloud has maybe 30 billion stars, and the small cloud has even fewer. They are orbiting us just like the Moon orbits the Earth, but their orbit is not stable. The immense gravity of the Milky Way is tearing them apart. We can see a vast looping stream of hydrogen gas called the Magellanic Stream that has been ripped from these two galaxies and now encircles our own. Their messy or irregular shape is because of us. Our gravity is stretching them, harassing them. This gravitational abuse is also triggering star formation inside them. The Large Magellanic Cloud contains the Tarantula Nebula, one of the most active and violent star-forming regions in the entire local group. These two galaxies are on a death spiral. They are being slowly consumed. In the next few billion years, they will be completely shredded and absorb their stars and gas accreted, or added onto the Milky Way. This is galactic cannibalism, and it's how we grow. The Milky Way is a predator and the Magellanic Clouds are its current meal. This is the nature of our local group. It is not a static, quiet neighborhood. It is a dynamic, evolving, and sometimes violent place. It's a place where galaxies are born, where they live, and where they merge to create new, grander structures. We are not just in the universe, we are part of the grand, ongoing cosmic process of change. For the past part of our journey, our sense of scale has been expanding, but we have still been in a way local. We've talked about our home, the Milky Way. We've discussed its neighbours, the Andromeda Galaxy, and the small cluster we call the local group. We've even looked at the Virgo cluster, a collection of over 1,000 galaxies, to which our local group is just a small outlying suburb. But now we must perform the largest zoom out imaginable. We are going to unpin our location. We are going to stop looking at our street, our town, or even our country. We are going to look at the entire globe of existence. This is part 4, the big map, the cosmic web. If you expected the universe to be a random scattering of galaxies like dust motes floating aimlessly in a sunbeam, you would be mistaken. The universe is not random. It is not a uniform soup of stuff. On the very largest scales, the universe has a structure. It has an architecture, and it is perhaps the most profound and unexpected discovery in modern cosmology. What we see when we map the locations of hundreds of thousands, even millions of galaxies is not chaos. It is a pattern. A breathtaking, enormous pattern. Gravity, as always, is the architect. Just as it pulls planets around a star and stars into a galaxy, gravity pulls galaxies toward each other. These galaxies form groups. The groups are pulled together to form clusters, and the clusters in turn are pulled together to form the largest known structures in the cosmos superclusters. This leads us to our true cosmic address. We thought we were in the Milky Way within the local group on the edge of the Virgo cluster. But this entire arrangement, our cluster and thousands of others, is itself just one small part of an even grander system. The local group is moving. It's being pulled along with 100,000 other nearby galaxies toward a single massive point in space. This structure, this continent of galaxies bound by a common gravitational flow, is our home. It is called Laniakea. The name is Hawaiian and it means immeasurable heaven. It is a fitting name for a structure so vast that light itself takes 500 million years to cross it. Laniakea is not a thing in the traditional sense like a galaxy is with a visible edge. It is a watershed. Imagine a map of a continent with mountains and valleys. Rain that falls on one side of a mountain ridge will flow to one ocean. Rain that falls on the other side will flow to another. Laniakea is a cosmic watershed. Every galaxy within its boundaries, including our own, is flowing toward a common center, a supermassive gravitational anomaly known as the Great Attractor. We are a drop of water in a river, and that river is 500 million light-years wide. And what is this Great Attractor? We don't fully know. It is a mystery. Its location lies in a direction that is obscured by the gas dust and stars of our own Milky Way's disk, in what we call the zone of avoidance. We know it's there not because we can see it, but because we can see its influence. We can measure the motion of our galaxy and all our neighbours all being dragged toward this one point at over 600 kilometers per second. We are pulled by a ghost we cannot see. But even Laniakea, as mind-bogglingly huge as it is only one part of an even larger structure. It is one province in a global empire. When we zoom out even further past the scale of superclusters, we finally see it. The grand design. The universe is a web. It is an intricate, luminous, three-dimensional network. Scientists often describe this as a cosmic web or a sponge structure. Both analogies are accurate. Imagine a giant kitchen sponge. It's not solid. It's made of connected pathways of a material, and in between those pathways are large empty holes. This is the universe on the grandest scale, the spongy parts. The connected pathways are called filaments. These are colossal thread-like structures of matter, mostly invisible dark matter, stretching for hundreds of millions of light years. And like dew on a spider's web, the galaxies, the normal matter we can see are strung along these invisible threads. The galaxies are the beads on a string. They flow along these filaments like cars on a superhighway, all funneling toward the great intersections. The superclusters like Laniakea are not isolated islands. They are the junctions of the web, the brightest and densest knots where multiple filaments meet. They are the megacities of the cosmos where thousands of galaxies are crashing and merging together in a slow-motion cascade of gravitational energy. How do we even know this? We can't see the web, we map it. Astronomers point their telescopes at a single patch of sky and they measure the redshift of every galaxy they can see. This redshift caused by the expansion of the universe tells us how fast a galaxy is moving away from us, and from that we can calculate its distance. By doing this for millions of galaxies, plotting each one as a single point, we move from a flat two-dimensional picture of the sky to a living three-dimensional map of the cosmos. Projects like the Sloan Digital Sky Survey and the 2DF Galaxy Redshift Survey have been the great cartographers of this new world, revealing the sponge, the web, this grand interconnected structure. This structure was imprinted on the universe from the very beginning, in an instant after the Big Bang. In that first super-hot moment, the universe was almost perfectly smooth, but it contained tiny quantum fluctuations regions that were just a fraction of a percent denser, or less dense than their neighbours. As the universe expanded, these fluctuations were stretched to enormous astronomical scales. The denser regions had more gravity. This is where the dark matter, that mysterious substance that makes up about 85% of all matter, came in. It began to clump in these denser regions, and because dark matter has so much gravity, it created a gravitational scaffolding. The normal matter we are made of the hydrogen and helium gas then fell into this scaffolding, like water settling into the lowest points in a landscape. The gas cooled, collapsed, and formed the first stars and galaxies. The result is this web. The galaxies exist where they do because the dark matter scaffolding told them to. They are tracing an invisible architecture that has governed the cosmos for 13 billion years. But if the universe is a sponge, what about the holes? If the filaments are the luminous highways of the cosmos, what about the vast dark countryside in between? These are the voids, and they are perhaps the most unsettling and profound feature of the grand-scale universe. The filaments and superclusters, though enormous, only make up a small fraction of the volume of the cosmos. Most of the universe is empty. I do not mean empty like the space between Earth and the Moon, which is filled with faint solar wind. I do not even mean empty like the space between stars, which is filled with sparse gas and dust. I am talking about spaces so large they defy comprehension. Spaces so empty they are almost pure unadulterated nothing. A typical void can be 100 million to 300 million light-years across. Inside these voids there is almost nothing. A few stray lonely galaxies, perhaps like lost ships on a featureless ocean, but mostly nothing. No stars, no light, no matter, no dark matter, just expanding space. There is a famous one, the Bootes Void, discovered in the 1980s. It is a roughly spherical region about 330 million light-years in diameter. When it was first discovered, astronomers found only a handful of galaxies in a space that should have contained thousands. It was nicknamed the Great Kite. These wrote nothing. This is the deep emptiness. This is the silence. To travel into a cosmic void would be the most profound isolation imaginable. Imagine flying your starship in a straight line for 10 million years at the speed of light. You would see nothing. No new stars, no new galaxies. The familiar luminous web of light you left behind would shrink to a faint distant glow in one direction, while in every other direction there would be only an unchanging, absolute terrifying blackness. It is the darkness between the threads. This structure of filaments and voids tells us the story of the universe. It is a story of a battle between two great opposing forces. On one side there is gravity. Gravity is the force of collection. It is the architect of the filaments. It pulls matter together, builds galaxies and sculpts the great superclusters. It builds the cities of the cosmos. On the other side there is dark energy. This is the mysterious force that we discovered in the late 1990s. It is a property of space itself, causing the universe to expand at an accelerating rate. Dark energy is the force of separation. It is the master of the voids. It digs them out, expands them and makes them emptier, pushing the filaments further and further apart. The cosmic web is being stretched. The luminous cities are being pushed away from each other, isolated by the growing empty kingdoms of the voids. So when we look at the grand map of the cosmos, we see this dynamic, epic struggle. We see a luminous network of life and creation set against a backdrop of accelerating empty darkness. This map, this web, is the ultimate context. It shows us where we are a speck of light on a single thread in an immeasurable web, and it shows us where we are going, accelerating away from everything else on a journey into an increasingly lonely future. It is the story of everything written in the largest handwriting possible. How do we know any of this? We haven't travelled to other stars, and we certainly haven't visited another galaxy. How can we speak with any confidence about things that happened billions of years ago, billions of light years away? The answer is simple, and it's the hero of our entire story. Light. Light is our messenger. It's the only thing that travels from these distant objects and arrives here on Earth, carrying a physical record of the cosmos. Think of every ray of light as a postcard sent from the past. It's not an instantaneous message. It takes time to cross the vast ocean of space. When we catch that light, we are reading a message that has been travelling for millennia or millions or even billions of years. This light is packed with information. It's not just illumination. The colour of the light tells us an object's temperature. Hotter things glow blue, cooler things set below things glow red. But it's even more clever than that. We can spread that light out into a rainbow, its spectrum, and read it like a barcode. This barcode tells us exactly what an object is made of. We know the stars are made of hydrogen and helium, not because we've taken a sample, but because the light itself carries the chemical fingerprint of those elements. It also tells us how things are moving. When a galaxy is moving away from us, the very fabric of space stretches, and the light travelling through it gets stretched too. This stretching, which scientists call redshift, is the single biggest clue that our universe is expanding. All this information, its age, its temperature, its composition, its motion, is written in the light. We just had to learn how to read it. This is where the most mind-bending concept comes into play. Because light takes time to travel, every telescope is a time machine. This isn't science fiction. It is a literal physical fact. The speed of light is incredibly fast, about 300,000 kilometers every single second. But space is incomprehensibly big. When you look at the moon, you are not seeing the moon as it is right now. You are seeing it as it was about 1 second ago, the time it took for its reflected light to reach your eye. When you look at the sun, you are seeing the sun as it was 8 minutes ago. If the sun were to suddenly vanish, we wouldn't know about it for 8 full minutes. The light from the nearest star system, Alpha Centauri, takes over 4 years to reach us. When we look at that star, we are seeing 4-year-old news. Let's go bigger. The beautiful Andromeda Galaxy, our closest large galactic neighbour, is 2.5 million light-years away. The light we see from it tonight left that galaxy when our earliest human ancestors were just beginning to walk the Earth. That light has been travelling through intergalactic space for 2.5 million years, long before any human civilization, long before the last ice age. So what happens when we use a powerful telescope to look at a galaxy that is 1 billion light years away? We are seeing it as it was 1 billion years ago. What about a galaxy 10 billion light years away? We are seeing 10 billion-year-old light. We are quite literally looking into the past. The farther away we look in distance, the deeper back we look in time. For a long time this was just a theory, but then we built telescopes powerful enough to test it. The most famous test was done by the Hubble Space Telescope. In 1995, astronomers made a very brave decision. They decided to point the world's most powerful telescope at a tiny, insignificant patch of sky. This patch was chosen specifically because it looked empty. It was a speck of blackness near the Big Dipper, about the size of a grain of sand held at arm's length. They aimed Hubble at this nothing, and just let the camera's shutter stay open, collecting light for over 100 hours. Many thought this was a huge waste of time. When the image finally came back, it changed human history. The darkness was not empty. That tiny speck of sky was filled with over 3,000 objects. And they weren't stars. They were galaxies. Every smudge, every pinwheel of light was an entire galaxy, each containing billions of its own stars. This was the Hubble Deep Field. It was a core sample of the universe's history. We saw galaxies at all different stages of their lives, all in one snapshot. Recently, the James Webb Space Telescope did the same thing, but even better. Because Webb is designed to see infrared light, the stretched light we talked about, it can see even further back in time than Hubble. When Webb took its first deep field image, it shattered records. It found galaxies that are so far away we are seeing them as they were just 300 or 400 million years after the Big Bang. That is over 13.4 billion years in the past. We are not just looking at history, we are looking at the very first chapter. We are finally truly seeing the dawn of the universe. So what do they look like, these baby galaxies from the dawn of time? They look nothing like our own calm, majestic Milky Way. Our galaxy is a mature, stable adult. The galaxies Webb is finding are cosmic infants, and infancy is a chaotic, messy and violent time. These first galaxies are not the beautiful organised spirals we see today. They are small, clumpy and irregular. They look like shattered pieces of light. They are glowing with an intense blue light, which is the signature of massive, incredibly hot young stars. These first-generation stars were giants, hundreds of times more massive than our Sun. Because they were so massive, they lived fast and died young. They burned through their hydrogen fuel. In just a few million years, our Sun will live for 10 billion, and then exploded in universe-changing events called supernovae. These explosions were the furnaces that forged the first heavy elements. The universe was born with only hydrogen and helium. Every atom of carbon in your body, every atom of oxygen you are breathing, every bit of iron in your blood. It was all created inside a star and thrown out into space by one of these explosions. These baby galaxies are also crashing into each other constantly. The early universe was a much smaller place, and these clumps of matter were pulling each other together with gravity merging, colliding and triggering furious bursts of new star formation. What we are seeing in the Webb Deep Field is not a calm, quiet nursery. It is a cosmic construction site. It is a period of intense, violent, glorious chaos. And it is from this chaos that everything we know, including our own galaxy and our own planet, was eventually born. These messy, hot, chaotic clumps are the seeds of everything. We have travelled across the vastness of space, explored the architecture of galaxies, witnessed the life and death of stars, and ventured into the profound mystery of black holes. We have discussed the invisible structures of dark matter and the accelerating expansion driven by dark energy. Now we must face the ultimate question. Where did all of this come from? How do you tell the story of the beginning of time? How do you describe the birth of everything? We call it the Big Bang. This name is perhaps the most misleading name in the history of science. When we hear it, we imagine a massive explosion, a cosmic firework detonating in the center of a dark, empty room. We picture chaos and noise, a violent event in space. This is not what happened. The reality is far stranger and more profound. The Big Bang was not an explosion in space, it was the expansion of space itself. It's a difficult concept to grasp because our minds are built to experience a world inside of space and time. But in the beginning there was no outside. There was no before, at least not in any way we can measure. There was no room for the universe to explode into. The universe was the room. Imagine a single point, a concept astronomers call a singularity. This point is not just small, it is infinitely dense. It contains all the energy, all the matter, and all the space that would ever make up our entire cosmos. This single point is the entire universe. And then it begins to expand. The simplest analogy, though imperfect, is to imagine the surface of a balloon. Let's draw tiny dots on this balloon and let each dot represent a galaxy. Now begin to inflate the balloon. What happens? The dots move away from each other, but the dots are not walking across the balloon's surface. The surface itself, the very fabric of space, is stretching, carrying the dots, the galaxies, along with it. From the perspective of any single dot, it looks like all the other dots are rushing away from it. This is exactly what we observe in our own universe. The expansion of space is the engine of creation. The Big Bang is not a moment in the past. It is a process that is still happening right now. Let us rewind the clock. Let us go back to the very first moments of that expansion. The conditions here are beyond anything we can replicate on Earth. They are conditions of unimaginable heat and density. We cannot yet speak of the first second, we must speak of the first fraction of a second. In the first tiny sliver of time, a fraction of a second, so small it defies imagination, the universe is a boiling, chaotic inferno. It is millions of degrees hotter than the center of our sun. It is a state we call a quark-gluon plasma. In this state, nothing we recognize today can exist. It is too hot for atoms. It is too hot for the protons and neutrons that make up the center of atoms. It is even too hot for the quarks, the fundamental particles that to build protons and neutrons to stick together. The universe is a seething soup of fundamental particles and energy, indistinguishable from one another. The four fundamental forces of nature that govern our reality, gravity, electromagnetism, and the strong and weak nuclear forces, are believed to be united, acting as a single unified superforce. But the universe is expanding, and as it expands, it cools. This cooling is the most important theme of the early universe. As the temperature drops, the very physics of reality begins to change. The forces of nature freeze out, separating from one another. As the universe continues to cool, it passes a critical threshold. Suddenly it is cool enough for the quarks to condense. The strong nuclear force can now grab hold of them, binding them together in threes. For the first time, the universe has protons and neutrons, the building blocks of all future matter. We are still in the first second of existence. This soup is now a mix of protons, neutrons, and other particles like electrons, all swimming in a brilliant bath of high-energy light called photons. The universe is still expanding, still cooling. Now we enter a period that scientists call the first 3 minutes. This is the universe's first great act of creation. The cosmos is now cool enough for the protons and neutrons to start sticking together. This is Big Bang nucleosynthesis. Protons, which are the nuclei of hydrogen, begin to fuse. A proton and a neutron fuse to form deuterium or heavy hydrogen. Deuterium fuses to form helium. In just a few minutes, the entire universe sets its cosmic recipe. It determines the elemental abundance that will define the cosmos for the billions of years to come. When the 3-minute mark passes and the universe cools further, this process stops. The result. The universe is now composed almost entirely of hydrogen nuclei, about 75%, and helium nuclei, about 25%, with tiny traces of lithium. This is the raw material from which all future stars, planets, and life will be built. But we are not there yet. For the next 380,000 years, the universe remains in a strange state. It is a fog. Even though the building blocks of atoms, the nuclei and the electrons, exist, it is still too hot for them to combine permanently. The electrons are free-roaming, buzzing around with incredible energy. The problem is that these free electrons are experts at interacting with light. The photons, the particles of light, cannot travel. They move an inch, hit an electron, scatter, move, another inch, hit another electron, and scatter again. The universe is opaque. It is like being inside a cloud or a thick glowing fog. Light is trapped, unable to travel freely. This hot, dense fog fills all of space. But the expansion continues. The universe keeps stretching and the temperature continues to drop. After 380,000 years of this, the cosmos reaches a second critical threshold. The temperature drops to about 3,000 degrees Celsius, roughly the temperature of the surface of a red star. This is just cool enough for the hydrogen and helium nuclei, with their positive electrical charge, to finally and permanently capture the negatively charged electrons. The electrons settle down into orbits around the nuclei. Suddenly atoms are formed. This moment is known as recombination, and it changes everything. When the electrons are locked into atoms, the fog vanishes. The photons that were previously trapped bouncing endlessly off free electrons are now free. The universe in an instant becomes transparent. This is the moment of the first light. A colossal flash of light is unleashed, filling all of space. This is the oldest light in the universe, the echo of our creation. It is the first time the universe could see. This light has been travelling been travelling through space for 13.8 billion years, streaming toward us from every direction. Of course, we cannot see it with our eyes. The universe has expanded tremendously since this light was released. As space has stretched, it has stretched the wavelength of this ancient light. It started as a bright, hot, yellowish-orange glow, but the expansion has stretched it, shifting it all the way down the electromagnetic spectrum past red light, past infrared, and into the microwave range. We call it the cosmic microwave background, or the CMB. This is the warmth left over from the dawn of time. When astronomers point our sensitive radio and microwave telescopes at the sky, they find it. If they point at a distant galaxy, it is there. If they point at the black, empty space between the galaxies, it is there. It is everywhere. It is the most profound and important discovery in all of cosmology. It is the baby picture of our universe. This ancient light is not perfectly uniform. It has tiny, minuscule variations in temperature. These tiny hot and cold spots are the seeds of creation. The slightly denser spots are where gravity would over millions of years begin to pull matter together, the first seeds of the first galaxies. When you look at a map of the cosmic microwave background, you are not looking at an artist's impression. You are looking at a photograph of the universe as it was 13.8 billion years ago. You are seeing the echo of the Big Bang written across the entire sky. When we look up at the night sky, we see a universe painted with light. We see the glowing pinpricks of stars, the hazy smudges of distant galaxies, and the beautiful swirling arms of our own Milky Way. For centuries, we believed that this was the universe, the stuff we could see. We built our laws of physics on this assumption. We measured the mass of stars, counted them up, and added the mass of the great clouds of gas and dust floating between them. We felt we had a good inventory. We used our most fundamental law, Newton's law of gravity, to calculate how all this stuff should move. And for things nearby, like planets orbiting our sun, the math worked perfectly. But when we pointed our powerful telescopes at other galaxies, the math fell apart. This wasn't a small error, it was a profound universe-breaking contradiction. The problem was simple galaxies are spinning. Think of it like spinning a weight on the end of a string. The faster you spin it, the more pull you need on the string to keep the weight from flying away. In a galaxy, the string is gravity, the weight is a star. The pull comes from all the mass at the centre of the galaxy. Just like in our solar system, where the inner planets move fast and the outer planets like Neptune and Pluto move very slowly. And astronomers expected to see the same thing in other galaxies. The stars near the bright dense centre should be moving quickly. The stars on the far dim outer edges should be moving very slowly. If they moved too fast, the weak pull of gravity from the visible stuff wouldn't be enough to hold them. The string would snap and the stars would be flung off into the darkness of intergalactic space. In the 1960s and 1970s, an astronomer named Vera Rubin decided to test this. She was a meticulous and persistent scientist working in a field where women were often discouraged from tackling the big questions. Using a new highly sensitive piece of equipment, she and her colleague Kent Ford began to patiently measure the speed of stars in the Andromeda Galaxy, our closest spiral-shaped neighbour. What she found was not just surprising, it was impossible. The stars on the outer edge of the Andromeda Galaxy were not moving slowly. They were moving incredibly fast, just as fast as the stars much closer to the centre. This became known as the galaxy rotation problem. The string of gravity from all the visible stars and gas was nowhere near strong enough to hold on to those speeding outer stars. According to all the laws of physics, we knew the Andromeda Galaxy, and indeed almost every galaxy we looked at, should be tearing itself apart. They should be disintegrating before our very eyes. But they weren't. They were stable. They were holding together perfectly. Vera Rubin was faced with two possibilities. Either our most fundamental understanding of gravity, a law that had worked for centuries, was completely wrong, or there was something else there. Something massive. Something invisible. Something that was providing the extra gravitational pull needed to keep these galaxies from flying apart. She had discovered the first strong evidence for what we now call dark matter. This name can be misleading. It isn't dark in the way a black cat or a piece of coal is dark. A black cat is dark because it absorbs the light that hits it. A cloud of dust in space is dark because it blocks the light from behind it. Dark matter does neither. It is perfectly, completely invisible. It does not emit light, It does not absorb light, it does not reflect or block light. It is utterly transparent to every kind of light we have, from radio waves to X-rays. It is not something scary or spooky. It is perhaps the most important component of the cosmos. The best way to think of it is as the invisible scaffolding of the universe. Imagine you are building a vast, magnificent city. Before you can lay the first beautiful marble stone, you must first build a huge complex and mostly hidden framework of steel beams and supports. This scaffolding defines the shape of the city where the towers will be, where the bridges will connect, and where the great halls will sit. In the very early universe, dark matter was this scaffolding. Long before the first stars ignited dark matter, which feels the pull of gravity, began to clump together. It pulled itself into a vast three-dimensional structure stretching across the entire cosmos, a cosmic web of enormous filaments and massive invisible halos. The normal matter, the atoms of hydrogen and helium that would one day become us, was pulled by gravity into this pre-built framework. Normal matter fell into these gravity wells created by the dark matter, like rainwater flowing into a network of invisible riverbeds. Because the normal matter gathered in these specific places, it became dense enough to ignite and form the first stars. Those stars gathered to form the first galaxies. The visible galaxy we see, the beautiful spiral of stars, is just the city built on top of the scaffolding. The galaxy exists where it does and has the shape it does because it is sitting inside a much larger spherical halo of invisible dark matter. The dark matter is the foundation. It is the hidden framework that holds the entire structure together. This stuff is truly ghostly. It does not seem to interact with normal matter at all except through gravity. As you sit here reading this, scientists believe that billions or even trillions of dark matter particles are streaming through your body, through the chair you're in, and through the entire Earth as if it were all empty space. They pass through us like ghosts, never touching a single atom, never leaving a trace. This leads to the most humbling realization of modern science. If you were to take an inventory of all the stuff in the universe, all the energy and all the matter, you would find a shocking result. Everything we have ever seen, touched or measured, every star, every planet, every person, every black hole, every nebula, all of it, what we call normal matter, adds up to less than 5% of the total universe. We are the rounding error. We are the tiny luminous froth on top of a vast dark cosmic ocean. About 27% of the universe is the dark matter we just discussed, the invisible scaffolding that holds our galaxies together. The rest, a staggering 68%, is something even more mysterious, a force known as dark energy. This is not matter at all. It is some kind of energy embedded in the fabric of space itself that is causing the universe to expand faster and faster, pushing the galaxies apart. When you add these two together, you arrive at the profound and unsettling truth. 95% of the universe is invisible to us. We are living in a cosmos whose fundamental nature is a complete mystery. We can only see the 5% that manage to light up. Vera Rubin's observations didn't just find some missing mass. She opened the door to a new reality, showing us that the universe we see is only a tiny, fragile fraction of what is actually out there. For decades we had one big question: will the universe expand forever, or will gravity eventually win? Think about it like throwing a ball straight up into the sky. You know gravity is pulling it down. If you throw it softly, it will slow down, stop and fall back to your hand. If you throw it incredibly hard with escape velocity, it will still slow down, but it will have enough energy to escape Earth's gravity and fly off into space forever. We thought the universe was the same. The Big Bang was the throw. The ball was all the matter and galaxies, and the gravity was, well, gravity, the combined pull of all the matter in the cosmos. Scientists were just trying to figure out if we had enough stuff, enough gravity to pull the universe back together in a big crunch, or if we would expand forever, slowing down as we went. In the late 90s, two separate teams of astronomers set out to measure this slowdown. They were using distant supernovae exploding stars that act as standard candles, a way to measure cosmic distances to see what the universe was doing billions of years ago. They were trying to measure how fast the ball was slowing down. What they found they couldn't believe. The ball wasn't slowing down, it was speeding up. This was discovery that shattered everything we thought we knew. It was like throwing a ball in the air, watching it slow down for a second, and then watching it suddenly ignite a rocket engine and blast away from you faster and faster. The universe is not just expanding, its expansion is accelerating. This is the great mystery. Something is out there not pulling, but pushing. We give this something a name, though naming it doesn't mean we understand it. We call it dark energy. Like dark matter, it is dark because we cannot see it. We can't detect it with any of our instruments, but its effect is unmistakable. While gravity works to pull galaxies together, Dark energy works to push the very fabric of space apart. And here is the strangest part: dark energy seems to be a property of empty space itself. It's a vacuum energy, a kind of tension in the fabric of reality. This means that as the universe expands and creates more empty space, more of this dark energy comes into existence. Think about it this way. In a small room, gravity is strong. You, the furniture, and the cat are all pulling on each other very weakly, but if the room suddenly expands, the space between you and the cat grows. Now imagine that this new empty space has an inherent push to it. The more the room expands, the more pushing space there is. This creates a runaway effect. More space leads to more dark energy, which leads to a faster expansion, which leads to even more space. On local scales in our solar system, in our galaxy, gravity easily wins. The Earth is not being pushed away from the Sun by dark energy. In fact, our own Andromeda galaxy is still heading right for us, and we will collide in a few billion years. Gravity dominates our neighborhood. But on the grandest cosmic scales across millions and billions of light years, dark energy is the new master of the universe. It is the dominant force, and its power is growing every day. We estimate that this mysterious force accounts for nearly 70% of everything in the cosmos. All the stars, planets, and people you've ever seen, that's less than 5%. This leads us inevitably to the final question. If the universe is speeding up, if this push is only getting stronger, what happens in the end? This is the ultimate fate of the cosmos. It's not the fiery big crunch we once imagined. Instead, it is a slow, cold, and quiet fading away. We call it the big freeze, or the heat death of the universe. This isn't an ending of tragedy and fire, but rather a slow, inevitable long sleep. Here is what it will look like over timescales that are almost impossible for the human mind to grasp. First, the night sky will empty. As the expansion accelerates, all the other galaxies and clusters of galaxies that aren't already bound to us by gravity will be pushed away. They will cross a cosmic horizon, accelerating away from us so fast that their light will one day be stretched out, reddened, and then simply stop reaching us at all. Future astronomers, if any exist, will look out into the void and see nothing. Only the stars of our own massive merged galaxy, the Milky galaxy. They might conclude they are completely alone in the universe, unaware that a rich star-filled cosmos ever existed. Then the stars within our own galaxy will begin to die. Star formation requires fuel, the vast clouds of hydrogen gas. This fuel is finite. Over trillions of years, all the gas will be used up. No new stars will be born. The big bright stars will have died long before. The only stars left will be the small dim red dwarfs which sip their fuel slowly. They will burn for trillions of years, bathing the remnants of dead solar systems in a faint red glow. But even they cannot last forever. One by one they will flicker and die, becoming cold dead cinders. The universe will be left with the corpses of stars, black dwarfs, neutron stars and black holes all drifting in an ocean of absolute zero. The universe will be dark. It gets even stranger. Over unimaginable timescales, so long that the age of the universe today would be a mere blink, even these remnants may dissolve. According to some theories, protons themselves might decay, meaning that atoms will fall apart and all matter will disintegrate into a thin, cold soup of stray particles. The only things left will be the black holes. And over even more time, through a process called Hawking radiation, even the supermassive black holes will evaporate, slowly leaking their energy back into the void until they too are gone. What is left? A universe that is cold, dark, and empty. A vast, thin fog of photons and other basic particles separated by infinite distances with no energy, no movement, and no new events. The universe will have reached its final state of maximum entropy. It is the ultimate lights out. A slow fade to black. A long, cold, and final sleep. We look up at the night sky filled with the billions of stars in our own galaxy, the Milky Way, and our galaxy is just one of billions of galaxies. With so many stars and so many planets likely orbiting them, the question is impossible to ignore. Are we alone? This question is the heart of what we call the Fermi paradox. It was named after the physicist Enrico Fermi, who during a casual lunch conversation asked a very simple but profound question. If the universe is so ancient and so vast, and if life can arise on other worlds, then alien civilizations should be common. And if they are common, at least some of them should be much older and more advanced than we are. They should have had billions of years to develop technology like interstellar travel. Even if they moved slowly, they should have been able to cross the galaxy by now, leaving signals or probes. Yet we see nothing, we hear nothing. So Fermi asked, Where is everybody? This is the paradox. The numbers tell us the universe should be teeming with life. The reality we observe is an empty silent sky. For a long time, we did not know if other planets even existed outside our own solar system. We only knew our 8 neighbours, but in the last 30 years, our telescopes have opened our eyes. We have discovered thousands of exoplanets, which are planets orbiting other stars. Based on what we have found so far, we can confidently say that billions, perhaps hundreds of billions of planets exist in our galaxy alone. These worlds are not all the same. We have found planets that are hot Jupiters, giant balls of gas orbiting extremely close to their stars. We have found worlds completely covered in water, true ocean worlds. We have found lava worlds where the surface is a single massive molten ocean of rock. And most importantly, we have found planets that are rocky like Earth and exist in the Goldilocks zone, also called the habitable zone. This is the perfect distance from their star, not too hot and not too cold, where liquid water could exist on the surface. Liquid water is the one ingredient that, as far as we know, is essential for life. The discovery of all these other Earths makes the Fermi paradox even more confusing. We have confirmed that the real estate for life is plentiful. The universe is full of potential homes. This means the problem is not a lack of opportunity. So why is there such a profound, deep quiet? This mystery is often called the Great Silence. When we point our radio telescopes at the stars, we listen for any signal that seems artificial, any message that is not just the random noise of space. We have been listening for decades. The result has been the same every single time: silence. Scientists and thinkers have many possible explanations for this silence. Some are hopeful, some are neutral, and some are deeply frightening. One possibility is that we are simply the first. Maybe the universe is a new neighborhood and we are just the first house to be built. Perhaps life itself is easy to start. Simple bacteria might be everywhere. But perhaps the leap from a simple cell to a complex, intelligent, tool-using creature is extremely difficult. It might require a billion-year chain of lucky accidents, a stable star, a large moon to stabilize the planet's tilt, the development of photosynthesis, the jump to multi-celled creatures, and the evolution of consciousness. If this is true, we are not just a civilization. We might be the civilization the first to look up and wonder. Another darker idea is called the Great Filter. This theory suggests that there is some kind of wall or barrier that all intelligent life eventually hits. Perhaps this filter is self-destruction. Maybe every civilization that reaches our level of technology eventually destroys itself through nuclear war, or by creating a runaway climate change, or by inventing a dangerous artificial intelligence. If this is true, the silence we hear is the silence of a graveyard. It means others did exist, but they all failed to pass the test. This, of course, makes us look at our own problems with a new sense of fear. Are we approaching our own filter? But there is another, more humble possibility. Maybe the universe is not silent at all. Maybe it is filled with sound, but we simply do not know how to listen. We are looking for signals that we would send like radio waves. But what if a civilization that is 1 million years older than us communicates in ways we cannot even imagine? What if they use gravity waves or neutrinos or patterns in the light of stars that we dismiss as noise? What if they use a technology based on science we have not discovered yet? Think of it this way. Ants on the ground might build a complex colony right next to a human highway. The ants are completely unaware of the civilization passing by the cars, the radio signals, the internet data zipping through the air. The humans and the ants exist in the same space, but on totally different levels of reality. Perhaps we are the ants. The universe might be a busy, noisy place full of conversations, but we are just primitive creatures who have not yet figured out how to tune in. We are left in this strange position. We are surrounded by endless possibilities, but have zero evidence. We do not know if we are the first, the last, or just the quietest ones in a cosmic city. But this silence, this rarity, changes how we should see ourselves. If it turns out that life, especially conscious life, is incredibly rare, then the life on this small blue planet is not just special to us. It is special to the entire universe. It means that every song we write, every piece of art we create, every scientific discovery we make, and every act of compassion we show is one of the only sounds in the cosmos. The silence does not make us small. It makes us precious. It makes our survival, our planet, and our connection to each other the most important things in a very large, very quiet universe. We are the ones, perhaps, who bring meaning to it just by being here and being aware. We have travelled an unimaginable distance tonight. We have stood at the edge of the observable universe looking back across 93 billion light years of expanding space. We have watched galaxies ignite and we have floated through the silent graveyards of stars. We have seen the birth of solar systems and the dance of planets, but now it is time to come home. Let us begin that journey back. Pull your mind away from the cosmic web, that vast, glittering scaffold of dark matter and light. Let the great clusters of galaxies fade into the distance. We fall back into our own local group past the swirling mystery of Andromeda and toward a familiar, comforting spiral. We find our own galaxy, the Milky Way, a beautiful, sprawling city of 400 billion stars. We are not aiming for the bright, chaotic centre. We are heading for the quiet suburbs out on a minor spiral arm. We see our star, a steady yellow-white beacon, our sun. We fall past the orbit of distant Neptune, past the rings of Saturn and the great red storm of Jupiter. We pass the asteroid belt, a reminder of a planet that never was, and we speed past the red dust of Mars. And then we see it. A single breathtaking blue and white marble suspended in the black. Earth. Our journey quickens. We plunge through the atmosphere past the thin, high clouds and down toward the dark continents. We cross oceans and mountains in an instant, seeking a city, a neighborhood, a single home. We drift through the roof, silent as a thought, and into this very room. Feel yourself return. Feel the gentle pull of gravity, a force we share with every planet and every star. Feel the air as it enters your lungs, a simple rhythmic breath. Feel the warmth of your own body, the weight of the blanket upon you, the subtle contact of your skin with the bed. You are back. After a journey across all of space and time, you're present right here, right now. And what is this body you have returned to? What is this complex breathing machine that you call self? This is the most incredible part of the story. The great astronomer Carl Sagan said it best. We are star stuff. This is not poetry, it is the literal physical truth. The universe, in its first moments after the Big Bang, was almost entirely hydrogen and helium, the simplest, lightest elements. There was no iron, there was no calcium, there was no carbon, there was no oxygen. In that early universe, there were no materials to build a planet, no elements to form a flower, and no atoms complex enough to build a human brain. So where did it all come from? It came from the stars. The very first stars were massive, burning through their simple hydrogen fuel in a frenzy. When they died, they exploded. In the unimaginable heat and pressure of that stellar death, they forged new, heavier elements. They were the first cosmic furnaces. Their children, the next generation of stars, were born from those enriched clouds. These stars lived and died, and in their own explosive ends, their supernovae, they forged even heavier elements. The iron that allows your blood to carry oxygen from your lungs to your brain. That iron was forged in the heart of a star that died more than 5 billion years ago. The calcium that makes up the bones that give you structure and the teeth you smile with. That calcium was created in a cosmic explosion that scattered its riches across the galaxy. The carbon that forms the basis of every cell in your body, the nitrogen in your DNA, the oxygen you just breathed in, every single one of these heavy atoms was cooked in a stellar core and then violently thrown out into space, seeding the cosmos with the ingredients for life. That cloud of stardust drifted for eons until gravity pulled it together to form our solar system, our sun, and our planet. And on this planet, over billions of years, that ancient star stuff organized itself. It learned to replicate. It became life. And eventually it became you. You're not just living in the universe, you are the universe. The cosmos is not something out there, separate from us. We are a part of it, born from it. We are its recycled and reimagined dust. And this leads to the most profound realization of all. For 13.8 billion years, the universe expanded and cooled. Stars burned and died. Galaxies collided. It was a spectacle of unimaginable scale and beauty, but it was all happening in the dark. The universe was majestic, but it was blind. It had no mind to comprehend its own beauty, no consciousness to feel awe at its own existence. Until now, until life emerged on this small planet and perhaps on countless others. Through us, the universe has finally woken up. We are the small accumulated bits of matter that through a long, complex journey have developed the ability to think, to feel, to question, and to understand. We are the universe's way of knowing itself. When you look up at the night sky and feel a sense of wonder that is not just you, that is the universe itself feeling wonder. When you study a planet or a particle or a poem, that is the universe studying itself. When you feel love for another person, that is the cosmos creating a bond of connection. It is easy to look at the vastness of space and feel small. It is easy to feel insignificant, a tiny temporary speck on a minor planet. But that is the wrong perspective. Our place in the universe is not to be measured by size, it is to be measured by significance. We are the part of the cosmos that is aware. That is not small, that is everything. Our lives are not meaningless because they are brief, they are precious because they are rare. We are the momentary glorious chance for a collection of atoms to pause to look around and to appreciate the grand story that created them. So as you lie here on the edge of sleep, let go of any feeling of being small or alone. You are neither. You are connected to the oldest stars. You are a sibling to the most distant galaxies. You are carrying the legacy of cosmic furnaces in your very blood. You are a precious and sacred and beautiful part of this grand unfolding story. Let that cosmic peace settle over you. You are exactly where you are supposed to be. You are home. Good night. Sleep well, you magnificent piece of the cosmos. Sleep well.